Hello to everyone from around the world, and welcome to today's MSDN Magazine webinar, Right-Sizing Agile Development, brought to you by Construx. My name is Gary Cocker. I'll be your moderator today, and there are just a few short messages before we begin. This webinar is designed to be interactive between you and the presenter, and you can ask a question during the presentation itself as the question occurs to you by typing it into the text area on the left-hand side of your interface and then clicking the Submit a Question button. Our presenter will answer questions near the end of this webinar, but you can enter your questions at any time. This presentation will also feature some detailed slides, and by clicking on the Enlarge Slides button, you can increase the size of the slide window on your interface, and those slides will continue to appear to advance automatically throughout the webinar. And now on to our presentation. Joining us today is Steve McConnell. Steve is CEO and Chief Software Engineer at Construx Software, where he writes books and articles, teaches classes, and oversees Construx's software development practices. Welcome, Steve. And at this time, I'd like to turn the presentation over to you.
Thank you, Gary. I'm very happy to be here today to talk about right-sizing agile development and share some of the lessons that we have learned in working with literally hundreds of companies over the last couple of years or last several years. What we're going to be talking about today is first lay some groundwork by talking about, in general terms, why agile development is even of interest. I want to spend a few minutes or a couple of minutes clarifying what we mean when we talk about agile. And then I'd like to dive into the important background on lifecycle models and how those relate to agile development. And then summarize what we have seen with the companies we've worked with, as well as other published industry reports in describing the most useful agile practices, and talk a little bit about determining how each of our participants today can determine what their agile profile is, and then summarize some keys to success in using agile. Turning to that first topic then of why agile development, why do we even care about this? Well, the original motivations for agile development consisted of several parts. One is that developers wanted less overhead. They wanted to spend more time doing what they saw as the real work of the project and less time focused on what was perceived as bureaucratic overhead. Clients and customers also wanted more flexibility to change their minds once the project was underway. We'd also had a track record in the software industry of seeing that traditional methods tended not to work very well when projects moved into more of an exploratory mode. And we also found that in some organizations, traditional methods had been in place long enough that they had become calcified. That is, they had become overly rigid and not really responsive to the business needs anymore, and also were not providing the transparency or visibility. The bottom line overall was that for certain kinds of software in certain organizations, traditional software development practices were not getting the job done. One of the ways to look at the motivations for Agile is to look at the way that value was delivered on a traditional, that is a sequential or waterfallish kind of a project. On a traditional sequential project, cost is incurred quite steadily as you work your way through the project. That is, as people work, their company pays for them and so on. Value, on the other hand, is not delivered in a manner that corresponds to the way the cost is incurred. In a waterfall project where you do all of your requirements work up front, then all of your architecture work, then all of your detailed design work, and then all of your construction work, you may not deliver any actual working software until very close to the end of the project, which means you could be through 90% of the way through the project. You may have incurred 90% of the cost, and you may at that point actually have 0% of the value to show. And so the value delivery really did not follow the cost incurral very well over the course of a project. Now, an alternative to that was incremental development. And we're not really talking about Agile yet. We're just talking about incremental, that is, delivering a project in smaller pieces. With incremental development, we can do a little bit of we can do a lot of our requirements work up front, but we can still do a little bit of design, a little bit of code, a little bit of test, and a little bit of release, or at least driving the software to a potentially releasable state. And this allows us to have the value delivery line more closely approximate the cost line. In other words, when we're 50% of the way done incurring costs on the project, we can be roughly 50% of the way through with delivering value. So that is the incremental view. Now, if we play our cards right, what we typically want to do in an iterative or agile project is deliver the highest priority functionality first. And what that means is that rather than having a kind of linear stair-step function as shown on the preceding slide, we deliver value in decreasing order, meaning that the early deliveries tend to deliver disproportionately higher value than the later deliveries. And so this implies two things. It implies first that the early value delivery is more rapid. It also implies that the later value delivery is less rapid as we deliver things that are of lower value. And so if we're taking a truly agile approach, one of the things that we're going to do as we get into the later parts of the project is recognize that the value of the functionality that we originally planned to deliver is now less than what we had delivered earlier, and we're going to be open to opportunities to see new ways to deliver value that allow us to step off that originally planned value delivery curve and actually deliver increasing value in later iterations. And so rather than just delivering the same value as we would have with a purely incremental approach, we at least in theory can deliver higher value by opening ourselves up to the prospect of identifying and then actually delivering better functionality as we work our way through the project. And so to summarize the general value of Agile, Agile consists of methods that not just passively support responding to change, but that actually actively create opportunities to incorporate change into projects in positive ways. When done well, Agile can deliver business value earlier in the development cycle. It gives an organization the option to cancel a project at any time and yet still have business value delivered for that partial project. If you're 80% of the way through the project, you can actually deliver something like 80% of the value rather than in a traditional mode where you may be 80% of the way through the project and deliver 0% of the value. It also creates the opportunity to incorporate more timely feedback from the customer and make changes in response to customer feedback before you go too far down in the wrong direction. The customer gets better visibility because there's no better visibility, I think, than actual software. And in Agile development, the emphasis really is on producing actual software. I think that what we've seen is that Agile is especially useful in a context where the schedule and the resources are fixed, and the mission is to provide maximum business value within a fixed schedule and fixed resources. And in particular, I think Agile grew up in a business systems context where often groups are on an annual budgeting cycle and the resources, that is the people they have to work for that year, are basically fixed for the year. And whether groups think of it that way or not, essentially that puts them into a case where the schedule and the resources are fixed and the mission really is to deliver maximum business value. And Agile is a very good fit for that. It can be a good fit for other contexts as well, which we will discuss momentarily. Turning then briefly to the next topic, what is Agile? We are at a state in the evolution of Agile where we actually do have to talk about this because Agile has been a moving target over the years. Originally, back in 2001, the Agile Manifesto described Agile as being an approach that values individuals and interactions over processes and tools, that values working software over comprehensive documentation, that values customer collaboration over contract negotiation, and values responding to change over following a plan. Now, all of these items were valued, but the pairs on the left, or the left side of each pair, was valued more than the right side. What we saw is that a number of methods either were developed as Agile methods or were subsumed under the Agile umbrella. That included methods like Tom Gilb's EVO approach, the DSDM, Dynamic System Development approach that had been developed in Europe, extreme programming, of course, Scrum, adaptive software development, and some other approaches. So what is Agile today? Well, I think 8 years after the original Agile Manifesto, the definition has changed somewhat. I think today we use the term Agile to describe something that is a development approach that is not waterfall, certainly. It is usually incremental, meaning developing the software in smaller pieces, not a big bang approach, but a small piece at a time approach. I say it is always incremental, but it is usually iterative, meaning usually we don't define 100% of our requirements up front, but we define them at least to some degree, piecemeal over the course of a project. There's a primary focus on flexibility. That is more of a focus on being able to change course in response to changing needs or better understanding of needs than long-range predictability. And especially there's a reduced emphasis on the long-range predictability of the combination of cost, schedule, and features. In practice, we find Agile associated with specific families of practice such as incremental and iterative practices. We see that it tends to be more code-focused than document-focused, as you would have expected from the original Agile Manifesto, and usually, but not always, but usually associated with minimal upfront requirements work. In some contexts, I think the term has been watered down to a degree that Agile really is really almost a synonym for modern, that is, modern practices that work. We're going to try to be a little bit more strict about the definition in the talk today. Another way to think about approaches to Agile development is to look at software development approaches as a continuum. And in this diagram, on the left side of the diagram, we see an emphasis on plan-driven life cycles. That is where predictability is really most important. And there we have approaches like pure waterfall and staged delivery. On the right side of the diagram, we have the life cycles that are much more strongly associated with Agile, where responsiveness is most important. And here we have pure Scrum and extreme programming. And then in the middle of the diagram, we really have what we at Construx refer to as strategy-driven life cycles. That is, life cycles that involve some amount of planning as well as some amount of flexibility. And we found that for many companies, this sort of hybrid approach really best meets the business needs, but we'll have more to say about that momentarily. So I'd like to turn now to a discussion of life cycle models and Agile development. By way of previewing this topic, I think it's important to understand that software development consists of several well-defined activities. We always have to do requirements in some form or other. We always have to do some kind of top-level or architectural design. We also do some kind of detailed design. We also have to do construction, that is actually creating the code. And then there's going to be some kind of testing by developers and also integration test. And then sometimes there's also system testing by an external group. Now, when we talk about these distinct activities, sometimes people assume that because we're talking about distinct activities, that implies that these activities must be done in phases. And that really is not the case. I think it's extremely useful to discuss these as distinct activities, regardless of whether they are broken into distinct phases or whether they are done in a highly overlapping manner. And that brings us really to the topic of lifecycle modeling. Lifecycle modeling refers to how activities are sequenced and partitioned into a life cycle. And what we have found for many years now is that the life cycle model is the dominant attribute of any method, whether it's an Agile method or a traditional method. In other words, much of the success or failure, much of the applicability of any method to a particular context is determined by the underlying life cycle model that that method is based on. When we look at specific Agile approaches, many of the strengths and weaknesses of those approaches, I would say most of the strengths and weaknesses of those approaches can in fact be explained by the underlying life cycle model. Now, on the margins, the specific techniques that are employed also make some differences, but we really can get something like 80% of the way to understanding why something works or doesn't by looking at the underlying life cycle model. To give examples of endpoints in this area, the two probably best known and extreme cases in life cycle models are 100% sequential, that is the waterfall model, versus 100% iterative. And I think extreme programming is a good example of that. When we develop in a 100% sequential way, we try to develop 100% of the requirements, then 100% of the architecture, then do 100% of the construction, and conclude by doing 100% of the system testing. On the other hand, when we try to be completely iterative, we break the project up into very small iterations, and within each iteration, we do 100% of the requirements for that iteration, but only for that iteration. Then we do 100% of the architecture for that iteration, but only for that iteration. And then we do 100% of the construction and system testing, again, only for that iteration. So these really are the two endpoints, 100% sequential versus 100% iterative. What we find is that if we take a step back from this, that we can describe the lifecycle models through an abstract model where we define the variations in terms of the balance between the work we do up front and the work we do within each iteration, and then the number of iterations. So we look at things like what percent of requirements do we try to do up front versus what percent of requirements do we try to do within each iteration. And we look at what percentage of design do we do up front versus within each iteration. And of course, that partly depends on what percent of requirements we do up front. We can't do all of the design up front if we don't do a great deal of the requirements work up front. And then we look at the number of iterations, whether a project is broken up into 0, or that is 1 iteration, or 3 iterations, or 12 iterations. That's a big driving factor as well. And a final factor is what percentage of testing, in particular system testing, do we do in each iteration versus at the end of the project. I should say that these are the variations. There are also some attributes that are not variations, that is, that are constant across all credible methodologies. One is that the goal, the defect removal goal within each phase is always to remove 100% of the defects in the software. Now, attaining that goal can be problematic, but the goal in any credible approach is always to remove all the defects that are present at that point. Of course, a wide variety of techniques are used in pursuit of that goal, and the effectiveness of those techniques varies a great deal. Now, using this approach, using this model, let's take a look at how some common development approaches are described in terms of this model. If we look at the code and fix development approach, we start with basically no requirements. We try to code our way toward a solution, and hopefully eventually we get working software that is releasable quality. The way code and fix tends to work, according to our model, is we don't do any of the requirements or design up front. We divide the project up into numerous small increments, and I put the word increments in quotes because that implies a level of planning, really, that is usually not present in code and fix. And our plan, to the degree we even have one, is to leave most of the testing to the end of the project. Basically in this diagram, the solid bars show what we intend to happen. The diagonal crosshatch bars show what actually happens. What we intend to happen is that we leave some testing to the end. What actually happens is that as we get toward the end of the project, we discover all kinds of requirements work that actually isn't done, that we have to do at the end of the project. We discover all kinds of design and development work that hasn't been done and we have to do at the end of the project. And then we discover all kinds of additional testing that hasn't been done in response to those additional requirements, design and construction. So what tends to happen in a code and fix project is we think we're on schedule for a long time, and then at the end, as we start to test the software and realize how far away from our goal we are, the wheels come off the project and we have a large explosion at the end of the project in terms of additional cost, schedule, and so on. Now, pure waterfall is the approach where we try to do all of the work in distinct phases, all of the requirements, then all of the architecture, and so on. And the way this tends to work out in practice is really better than code and fix, but not that much better than code and fix. So we try to do all of the requirements up front, then we try to do all of the design, then we go through one development increment, and our intent at that point is to go through full testing at the end and declare ourselves done. In practice, what happens is that as we get into testing, we discover errors in the requirements, gaps in the requirements, necessary changes in the requirements. That gives rise to additional detailed requirements work, additional design work, additional development work, and additional testing work. And so we end up with another unexpected overrun. Not quite as bad as with code and fix, but still often significant. Extreme programming, as a response to this, I think actually stacks up pretty favorably when it's done well and with discipline. We don't do any of the requirements up front. We don't do any of the design up front. And then we try to do 100% of the requirements, design, development, and testing within each iteration. What we've seen with extreme programming is that tends to work pretty well for the first few iterations. But as you get into later iterations, you discover increasing numbers of requirements changes, design changes, and development work. And so at the end, the additional requirements, design, development, and testing can range from a small amount to a large amount. And in the worst case, we've actually seen some instances where extreme programming projects actually fail to converge on a viable software system, and a project actually collapses under its own weight. Pure Scrum looks in many ways very similar to extreme programming. None of the requirements are designed up front. Numerous self-contained development increments where we do requirements, design, development, and testing within the increments. An important difference in Scrum between Scrum and at least the original version of extreme programming, though, is in Scrum we have the notion of a product backlog where we can get a more global sense of the overall scope of what we're trying to build. And from what we've seen, that tends to give rise to smaller changes in later iterations in requirements, new requirements or change requirements, design, and then the resulting design, development, testing, and so on. So I think with any methodology, we're never going to get a perfect result where we don't have any unexpected work whatsoever, but we see a minimal amount in the organizations that are making use of Scrum in a well-understood, well-trained, and disciplined way. Now, when we talk about Scrum, I think it's important to recognize that there are some variations on Scrum that can be effective. We've seen organizations do anywhere from 0 to 90% of their requirements up front in Scrum. We've seen them do anywhere from 0 to maybe 25% of their design up front. And we see many organizations using 2-week and 4-week or 30-day development increments. And ideally, none of the testing is left to the end. The testing is done completely within each iteration. In practice, we see a little bit of testing tends to stack up at the end, but hopefully in many cases we see not very much. So why this emphasis on lifecycle models? Well, as I said at the beginning of this section, many of the effects that have been attributed to Agile practices are really caused by the underlying lifecycle model. For example, if you go look at my book, Rapid Development, in Chapter 7, in my discussion of lifecycle models, there's a reference table that describes the strengths and weaknesses of the various lifecycle models. I list evolutionary prototyping as one of the lifecycle models, which is the lifecycle model that extreme programming is based on. Now, if you go through that table and you look at the detailed strengths and weaknesses of that lifecycle model, you will see an almost perfect match to what the industry now understands to be the strengths and weaknesses of extreme programming. Now, there's nothing in there about pair programming or continuous integration or refactoring, but the underlying lifecycle model strengths and weaknesses actually account for a lot of what works well and what doesn't work so well in that particular practice. And so my conclusion is that the choice of lifecycle model really is the defining attribute of an Agile method or any other method for that matter. And we find furthermore that whether the lifecycle model you choose is probably the biggest determinant in whether people will say that you're using an Agile development approach or not. It's also, I want to make sure that I make it clear that we can have virtually any variation on this theme of how many iterations do we have and how much of the requirements, design, and development work do we put within each iteration. The top row in this slide is really the highly iterative approach, such as pure Scrum or extreme programming. We could possibly go to shorter iterations, that is, longer iterations and a smaller number of iterations, as shown in the second row. We could possibly go to an even smaller number, such as 3 iterations, as shown in the third row. With that few iterations, we typically would be describing that as something more like stage delivery than extreme programming or Scrum. And I hope you can see the pattern that by the time we get down to the bottom row, with 1 iteration, we actually have a waterfall model. And what this suggests is that the main difference between the waterfall model and Scrum and extreme programming in a life cycle, from a life cycle point of view, really is 1 iteration versus many iterations. I also want to point out that we can have other kinds of breakdowns of the activities in the life cycle models too. There's nothing that says we have to iterate everything or iterate nothing. We could have iterations of requirements and design, multiple iterations up front, and then do 1 development cycle and 1 test cycle. I'm not recommending that, but that would be possible. Similarly, we could take a big bang approach to requirements, a big bang approach to design, and then go through many iterations of development and test, as shown in the middle line on this slide. Or we could go through multiple iterations of requirements and design, declare the requirements and design to be done, then go through multiple iterations on development, construction, and testing. For an organization that's in a strong stage gate environment, this can actually be a pretty effective approach. It allows you to be iterative to some degree while also still conforming to the organizational requirements imposed by a stage gate sort of a framework. And, of course, even in a waterfall approach, which I don't really advocate, I can't think of any circumstances I would advocate it, but if we were required for some reason to make the best of that, we could go through numerous iterations in requirements, then go through numerous iterations in architecture, then go through numerous iterations in development, and then conclude with system testing. And that would at least help us to make the best of a pure waterfall approach. So there are lots and lots of variations possible with lifecycle models, and I dwell on this point just because I think it is such an overriding factor in what makes a project approach successful or not. With that general framework in place, I'd like to turn now to a more detailed discussion of which Agile practices we have seen be most useful. And my objective in this section is to identify the specific practices that we've seen be most useful, and then to describe what we've seen as the industry experience with each of these practices. The industry experience comes really from two places. It comes first and foremost from my company, Construx Software's consulting and training experience in working with companies on agile practices, hybrid practices, and other practices. We've worked with approximately 1,000 companies over the past 5 years, so we have a fairly broad base of experience to draw from. I've also factored in other published industry reports in some cases. So the first practice, and I think probably the most important practice in terms of what really defines something as agile, and for that matter, defining something as effective agile, is the use of short release cycles. We see this in the 30-day sprints in Scrum, the 1 to 4 week iterations in XP, the weekly releases in Evo. Our assessment is it's important to recognize that release is sometimes purely internal. I like the way that the Scrum world tends to define that, which is bringing the software to a potentially releasable state. Not that you actually have to release it, but it's at least potentially releasable. And I think that this has emerged as a clear industry best practice. Moving to shorter release cycles addresses any number of common risks. It addresses technical risk. It addresses integration risk. It addresses proof of concept risk. It addresses management risk, like knowing what the status of the project is. It addresses the risk of not knowing until very late how much progress you're really making. And so I think we've seen that even in strong stage gate environments, even in environments that are mandating strong sequential approaches, finding some way to move to shorter release cycles, whether you're in business systems or safety critical systems, short release cycles are valuable almost all the time, virtually all the time. A second practice that we've seen that's generally useful is highly interactive release planning. We see this with the planning game in XP and with planning sessions to define the product backlog, estimate and plan in Scrum. It's interesting, really. The PMI, the Project Management Institute, has been advocating something they call rolling wave planning, where you have a long-term roadmap that goes out 2 to 12 months combined with a short-term detailed plan that goes out 30 to 60 days. And I think it's pretty interesting. The Agile World, Project Management Institute, and other roads are all converging to the same destination, which is some kind of coarse-grain, large-scale planning for general direction, and then leaving your fine-grained detailed planning for a fairly short planning horizon, something like 30 days. And I think this has clearly emerged as another industry best practice. A third practice that we've seen work well is Timebox Development. In Timebox Development, the idea is that you give the development team a rigid time box within which they are going to conform their development work, and in its pure form, the team commits to delivering its committed functionality by a fixed date. And in its pure form, if the team doesn't deliver everything, the work is thrown away, and so the time box is wasted. And this is supposed to create a high incentive to actually complete the committed work by the end of the time box. And we don't see time boxes practiced in their pure form very often. I mean, almost never. What we do see is 30-day sprints in Scrum, iterations in XP, and then time boxes in DSDM. And we think practiced as we tend to see them in practice, which is committing and doing the best you can to deliver the functionality in a relatively short kind of a sprint or iteration, does keep progress visible. I think it helps to keep the team morale high because they get the sense that they're part of a project that is heading towards success. It minimizes inflow requirements changes because it's very reasonable to say, hey, we've only got 30 days. We just talked about the requirements. We'll talk about additional changes after the iteration is over. And that's reasonable when your time boxes are short. It becomes a lot less reasonable when your development increments are 6 months or 12 months or something like that. And so what we've seen is that it appears to us that a series of sprints seem to be more sustainable for many teams than a straight 40-hour work week. That is, a lot of people seem to like the ebb and flow of working hard and then kind of relaxing for a short time and then working hard again. We also have found that empowered small cross-functional teams are a valuable practice that is often found within Agile projects. The idea behind this is that the team includes development, QA, management, maybe a coach, maybe a customer. The overriding factor here is that the team includes everyone who needs to be included to make decisions, to give input to decisions, and then to actually make those decisions binding and carry out the decisions. And it's interesting here that I think the concept is very similar to the feature team idea that was popularized by Microsoft and first documented in the book Microsoft Secrets. It really does allow for streamlined decision-making when you have all of the concerned parties on the team. It also allows for excellent execution because everyone who needed to be involved was involved, and that leads to high buy-in. So we think this is another pretty clear best practice that has really been emphasized in the Agile world. Another practice that we have seen in a very interesting way, especially considering some of the early writings in Agile, is involvement of active management. We see this in the role of coach in extreme programming or Scrum Master in Scrum. And I think the point here is that there are some approaches that are known as high discipline approaches. And what high discipline means is that without external accountability, people tend to fall away from high discipline approaches. And it doesn't even matter whether they agree with the approaches. Even if they agree with the approaches and are bought into them with high discipline approaches, they may still have a tendency to fall away from them. And it really helps to have external accountability provided by a coach or manager when you're using high discipline approaches. And some of the practices in the Agile world, some of the really effective practices are in fact high discipline practices that need that kind of support. I also think it's interesting to note that the Agile roles of coach and Scrum Master are essentially theory-Y style management, where theory-Y is the belief that most workers are ambitious, self-motivated, responsible, want to be self-directed, and are motivated by the opportunity to do good work. Theory-Y managers try to remove barriers that prevent workers from fully actualizing themselves and ensure they don't get bogged down by rules. It is interesting to me that it has taken Agile development to illustrate the benefit that engaged management can have on software projects, but I think in essence that is what has happened over the last several years with these roles of coach and Scrum Master. Coding standards clearly predated Agile by decades, emphasized strongly in extreme programming. I think this is a clear, long-standing industry best practice. Not a whole lot more to say about that. Frequent integration and test, we've seen through continuous integration in XP and other more ancillary to other Agile approaches. We think that continuous integration is a logical extension of the smoke test and daily build, given sufficient processing power to integrate more often. One of the things that is sometimes misunderstood about this is that you have to include the testing as well as the integration, or it isn't meaningful. If you're just integrating without testing, you don't really know whether your integrations have worked, and so the testing really is critical. We have seen in the organizations that we've worked with that this is sometimes hard to instill the discipline to build at least daily, if not more frequently in teams. So this is one of those high discipline practices I just mentioned. However, our conclusion is that overall it really is worth the effort to build at least daily, even if the startup is burdensome and even if it takes some organizational arm wrestling to get teams started doing this. We almost never see teams revert to less frequent builds once they go through the work of getting a daily build process or a more frequent kind of process institutionalized. Automated regression tests are another practice that we've seen generally work pretty well through the use of unit test frameworks. We think that with new development, this is virtually always a good practice. Sometimes with legacy development, we've seen this present some challenges, in particular figuring out how to retrofit a large legacy code base with unit tests can be quite an exercise just in determining which tests you need, and then accomplishing any kind of real test coverage can be problematic as well. We've also seen that if organizations don't apply the same level of quality standards to their tests that they create as they do to the code they're creating, that over time those tests can become brittle and can cause a lot of maintenance work on the test cases themselves. So we think that this is really an invaluable practice when it's used in an appropriate context and with appropriate discipline. Can be problematic when it is not used with care. Retrospectives at the end of each release, also a valuable practice. We see this in the heartbeat retrospective at the end of each sprint in Scrum. Iteration and quarterly reflections in extreme programming. I think that this is another clear best practice, and to some degree this is just common sense. If you pause every once in a while to take a look at what's working and what's not working, and then take corrective action, you can't help but get better over time. Daily stand-up meetings, also I think a good practice that tends to work pretty well. We see this in the 15-minute daily stand-up meetings in Scrum. We find that the public peer accountability is useful, also useful just for making sure that people do communicate on a regular basis, and that there's an emphasis on people not just sitting on problems but exposing those problems and getting help with those problems if they need them. And I think in general when this is practiced truly by the book, that is, you actually literally stand up, you focus on the three questions, and you conclude the meeting when you're done. I think that this seems to work quite well. Test first development, the idea that you write your test cases before your code, and as soon as you write your code, you immediately run the test cases to make sure the code works. Seems like another very good practice. It minimizes the time between defect insertion and defect detection. It spreads out the work of creating test cases so that developers are creating a good chunk of the test cases, not just testers. We find that it does, though, require a culture shift among developers. That is, developers have to get used to the idea that part of their job is creating test cases, and that can meet with some resistance we've seen in some organizations. Of the practices that I'm describing as generally useful Agile practices, this is probably the highest discipline practice and the one that we see dropped or compromised most frequently. Having said that, I think it's worth the effort to instill the discipline that this practice requires, and the reduction in quality-related risks that we see that accompany this practice definitely justify the work. The second to last practice that I'll mention specifically is on-site customer, and I think what we've seen is that the general idea of close customer communication is a good idea. The specific idea of on-site customer has been problematic, and so even within much of the Agile writing lately, the notion seems to have shifted from literal on-site customer to more of a project community. And the reason for this, there are several reasons for this. One is getting a full-time on-site customer representative is problematic, very seldom accomplished in practice. Second is that even if you can get one person full-time, that person isn't necessarily representative of your customer base at large, and we've seen some organizations put a lot of weight in the input from that one person, only to find as they near the end of the project that that person isn't representative, have a great deal of rework resulting from that. So we think involving the customer in some way, shape, or form is a really important idea. Certainly goes back at least to the original Standish Group Chaos Report in 1994, when they identified customer involvement as one of the top success factors for projects. But I think involving customers more broadly is really the operative idea here. Pair programming, the final practice that I'll mention, clearly strongly associated with extreme programming. Originally, this was presented as a universally applicable practice. I think the industry experience over the last several years has really settled in on pair programming being a good practice when used selectively. The sweet spot seems to be pairing junior and senior programmers. That can be a great way to onboard a new programmer or to bring a junior programmer up to the similar level of capability as the senior programmer. Many programmers prefer not to work this way, and they especially prefer not to work this way all the time. And so we have seen very few organizations stay with this full-scale practice, that is pair programming on everything, on any kind of a sustained basis. What we do see is organizations using pair programming selectively for purposes of onboarding new employee, or maybe for programming an especially complex or critical section of code. And we see lots of value in this practice when it's used selectively, less value when it is used in more of a wholesale manner. So with some specific practices under our belts, I'd like to spend a couple minutes now talking about how you can determine your Agile profile. That is, how Agile do you really need to be? One way to look at it is on what's known as a caveat diagram or a star diagram, where we look at a number of dimensions. In this case, the labels on these axes are labeled in such a way that the closer you are to the middle, the center of the diagram, the more Agile you can be. The closer you are to the edge of the diagram, the less Agile. So the top line is, let's go clockwise, starting from the top. The top line is whether your personnel tend to be more junior or senior. Then moving clockwise, the next line is requirements change, from moving from the inside to the out, from high change to low change. The next line is corporate culture, specifically how many of your people enjoy or thrive on chaos and have an entrepreneurial spirit. The bottom line is team dispersion, how dispersed are the team geographically, through time zones, and culturally. The next line is team size, how big are your teams? And the final line is product impact. What happens when there's an error in the software? Do you have a loss of life, many lives, a single life, essential funds, discretionary funds, or just sort of comfort or convenience? And by using this approach, we can take a look at whether a particular project really is well suited to Agile or not. In the next example, where we have fairly a moderate mix of junior and senior personnel, a moderate amount of requirements change, moderate number of people in the company who really thrive on chaos or have an entrepreneurial spirit. The team is not that dispersed. The team size is fairly small, and the product impact is fairly small. This is a pretty clear situation where Agile practices would be very, very appropriate. In contrast, if we change just a few of the assumptions somewhat, and we say that the team is greatly dispersed, and that the product impact is higher, and the team size is a little bigger, then what we find is that this really doesn't call for Agile to anywhere near the degree that the preceding example did. So the bigger the filled-in area becomes, basically, the less call for Agile we see. And so here the real determination is, where do you fall in this diagram? Do you have lots of senior people? Do you have high requirements change? Does your corporate culture thrive on chaos? Do you have relatively small teams that are mostly co-located? Well, that's a pretty good match for strong Agile development. On the other hand, if you have a lot of junior personnel, you have low requirements change, your teams are spread out through the world, and they're large, and the impact of error is high, then that really calls for a lower use of Agile practices. So I'd like to summarize now by talking about keys to success in using Agile. First, a few warnings. One warning is be aware that some of the Agile practices are, in fact, high discipline practices, which means if you push the charter for adopting Agile practices down to the level of an individual developers, that may not work, because you actually can benefit, or in many cases you actually need some external accountability, and if you don't have at least a manager involved, that can be problematic. Second warning is make sure that Agile practices really are what your business or project needs. If your business really values predictability over agility, and many businesses we have found do in fact value predictability over the ability to change your mind about your features, then you can make selective use of certain Agile practices, but you need to make sure that the specific practices you select are practices that support or enhance predictability, not practices that undermine predictability. And some Agile practices support, and some Agile practices undermine. So you need to be careful which ones you're picking. And I think, too, finally, I would caution organizations to have realistic expectations about the benefits. You will find once you've implemented Agile and once the initial enthusiasm is worn off that there are, in fact, some trade-offs. Even if you do it well, there can be benefits, and you can ultimately conclude that it was a good decision and you're glad and that the benefits made it worthwhile. But that doesn't mean that it's a benefit in every dimension. There will be trade-offs, and some things will get worse while other things, hopefully more things, get better. Common hurdles that we've seen organizations struggle with from time to time are how agile should you be. A big hurdle is how much requirements work should you do up front versus later. In a naive adoptions of agile practices, we'll see organizations that really need predictability and that value predictability embrace agile practices that allocate requirements work to their iterations rather than doing it up front. This can end up being a very bad match for the business needs of the organization and can end up leaving a business with a bad taste in its mouth about agile or Scrum or extreme programming, really unnecessarily. With a little bit of guidance about how to implement the right kind of practice, the same business could have made some selective changes in, let's say, Scrum, and had a very, very satisfying experience with their initial Agile adoption rather than an unsatisfying one. We see the same kinds of issues with how much design should you do up front, how long can your iterations be, which specific Agile practices are most effective. We also see larger organizations commonly struggling with questions like, well, how does Agile work with stage gate process? How do we fit that into the stage gate process? How does it work with SOX? Sarbanes-Oxley. How does it work in regulated industries? Well, we've worked with companies on each of these issues, and I can tell you that it is possible and indeed desirable to implement Agile in stage gate environments and in SOX environments and in regulated industries, but you have to be careful how you go about it. Finally, I'd like to summarize some keys to success. We have certainly seen many companies benefit from more incrementalism. I think it's almost universally true that companies can be more incremental, that is, do things in smaller steps. Iteration is often useful, though not always. You have to make sure that you understand that iteration is a broader concept than iterating the entire development cycle, and that it might involve just iterating within activities or across pairs of activities. The general principle here is that you should design your iteration loops to be as tight as possible. In other words, make the feedback that you get from the iteration as quick as possible. And if you're iterating in a risky area, you want to iterate quicker rather than longer, so that you get feedback on the risk at the earliest possible opportunity. To summarize then, we have seen numerous organizations do very, very well with Agile. We have seen occasionally organizations struggle with it. At this point, I'd be happy to open the floor to comments or questions.
All right, thank you very much. That was an excellent presentation, Steve. We'll move into the question and answer section of this presentation now. And as a reminder, if you have a question for Steve, please submit it by typing it into the text area on the left-hand side of your screen, and then click Submit right on your interface. We'll answer as many questions as we can as time permits. So if you're ready, Steve, we'll go to our first question.
I'm ready.
Okay, it's from William, and William is in San Antonio. Their company is moving to a partial offshore model. There are some internal debates going on over how best to specify requirements. We tend to be fairly agile, but do not see how that will work with an offshore provider. Do you have any advice in this regard?
Well, that's an interesting question, and it's a pretty common circumstance, actually. We certainly have seen the majority of companies that we've worked with over the last few years moving to partial offshore models. When William says offshore provider, that makes me think that the offshore group is not captive to his company. That would actually make a little bit of a difference. If it's actually a third-party offshore provider, then I think we really have a couple of factors that are auguring against being very agile. One is offshore, and that's one factor. Another is, and in offshore I include things like no face-to-face communication, probably not very high bandwidth communication, companies typically do that, motivated in large part to minimize costs, and unfortunately what that means is they tend to minimize travel back and forth, which can help to supplement the issues that come up with offshore. But if you're not doing extensive travel back and forth, then unfortunately the risks tend to multiply. So part of it is the time zone distribution, the cultural impedance, if you will, and then that is national culture, but also the differences in company culture. And I would assume a low level of understanding on the offshore provider's part of Williams' business. And so all of these factors basically say, call, I think, for more formality in the requirements rather than less. So I think that the one Agile practice that would be beneficial in a case like that is short iterations. Now, that's not short iterations that include requirements work within the iteration. That is to say, try to do as much of the requirements probably within your company onshore as you can, and then follow that up by having the offshore provider deliver results in short iterations. That'll allow you to keep tabs on their progress, make sure they're actually understanding your requirements, detect problems sooner rather than later, and it also allows you to monitor more generic issues like is the quality adequate, what is their productivity, is the project on schedule, and so on.
Very good. Thank you, Steve, and thank you, William, for the question in San Antonio, Texas. Next up, how should companies that haven't done much Agile development roll out Agile?
This is another great question. I think that one of the ways we don't like to see this done is basically just individuals within a company get excited about Agile and try it out without verifying with their business that it really is the right approach. So I think the first thing you need to do is make sure that Agile is responding to some actual business need. And we have seen Agile in some cases, or the specific implementations of Agile, be the proverbial solution in search of a problem. So the first thing to do is get very clear about what are the business needs and what business need is Agile responding to. And that doesn't mean the developers just talking amongst themselves. That means actually talking to business stakeholders in your projects and making sure they agree that those are the business needs. Once you do that, we have seen a couple cases with wide-scale rollouts of Agile where a company will roll out Agile practices to 100 or 200 people at a time. We've seen that work in one or two cases, but we've also seen some absolutely cataclysmic failures when Agile is adopted like that. So I think in general what we recommend is that you roll it out on a couple of pilot projects. And this is not as easy as it might at first appear. You want to roll it out initially, those pilot projects. You want people who are enthusiastic about the new practices, and those people tend to have the energy and the motivation to overcome some of the obstacles that you're going to run into. Once they have done that, now, though, the challenge is not over because as you try to roll it out more broadly in your organization, the second wave of adopters typically aren't going to have the same level of motivation and enthusiasm as the first wave. And so that's where you can really benefit from some explicit training and explicit coaching, either from the people who were involved in the initial rollout or through some external company like my company, Construx, to make sure that second wave of rollout goes smoothly and incorporates the lessons learned during the first wave of rollout and so on. So we definitely recommend an incremental approach and not getting too complacent about early successes with hand-picked pilot teams.
Okay, let's go up to Canada now to Edmonton for Brian's question. Could you provide some insight into your approaches dealing with Agile in a stage gate environment?
Sure. Many of the companies we work with, if not most, operate under some kind of stage gate environment. And so typically what that means is that there's an initial exploratory phase for a project. But once the project goes through the project approval gate, which in many cases is gate 2, the requirements are relatively fixed, and there are some pretty strong commitments for the combination of schedule, cost, and date, or schedule, cost, and features. So trying to fit Agile into a stage gate process basically means you're not going to be able typically to be highly iterative in the requirements. And so we have seen Scrum in particular work well in this context, where during the work in what is usually considered to be stage 0 and stage 1 or stage 1 and stage 2, you'll spend a lot of work defining your product backlog, which is really kind of a traditional requirements elicitation exercise. You'll put together your product backlog. You'll possibly commit to a feature set. And all up to that point, the approach can look pretty traditional. In fact, kind of hard to differentiate from a waterfall or a sequential approach. Once you get through the approval gate, though, now you can use all the Agile practices you want to, essentially, except those that are going to introduce large changes in requirements. You can use Scrum and sprint planning to define which features you're going to allocate to each sprint or iteration. You can use short iterations to provide the visibility, transparency, and technical risk reduction that you get from Agile. And you can break the project up into relatively small, relatively self-managing teams, as I described earlier in the presentation. So really the key is not terribly Agile getting up to the official commitment gate, but then almost indistinguishable from other kinds of Agile projects after you get through the commitment gate, except that you may not have as much latitude in changing requirements as you would in a full-blown Agile implementation.
Next question comes in from Charlotte, North Carolina, from Scott. How do you plan on funding for a project in which you don't have all the requirements up front? Upper management typically wants to know what the total damage will be. But with this approach, it's hard to pinpoint, says Scott.
Well, Scott asked an excellent question, and I think this is exactly what I was referring to when I said that sometimes or often certain implementations of Agile are the proverbial solution in search of a problem. In fact, I think upper management usually values predictability implied by Scott's question, and so you do, in fact, have to be really careful when you go in and talk to your boss or upper management. Sometimes we see people talk to their boss or upper manager and say things like, we can give you all kinds of flexibility to change your mind. And the upper manager will say, I don't want the flexibility to change my mind. I want to know what I'm going to get, and I want to know it as early as possible. So that basically brings me back to the same answer as the answer to the previous question, which is, previous couple of questions, which is make sure that you understand what the real business priorities of your organization are, and make sure that the specific Agile practices you select support those organizational priorities. And we see that one of the great ironies of the Agile movement is that it started out really downplaying predictability and playing up flexibility. I think that actually was non-responsive to the most common business need, which is a higher need for predictability and a lower need for flexibility. The ironic part of this, though, is that when you play your cards right, Agile practices can actually increase predictability as you work your way through a project, particularly in using practices like story points and burn-down charts in Scrum, which can really increase predictability and confidence in a schedule. So while I think in the early days the Agile community tended to downplay that, these days at least certain segments of the Agile community have recognized that, wow, we've actually got a powerful technique here, and we need to apply it to the businesses that are asking for it.
Dave's question from Canada. Often a desire to implement an Agile methodology starts and is supported by the grassroots of an organization. But getting upper management to buy in is difficult. Do you have any best practices or suggestions for helping grassroots Agile movements gain traction and or approval from reluctant management?
Well, I have two kind of separate responses to that question. One is, and they're really quite different answers. One is, depending on what specific practices you're talking about, many of the Agile practices are not visible to upper management, and you don't need upper management's buy-in. And I'm not saying that in a devious way. I'm really saying it based on the fact that if there's a way to do your job that is truly more effective, and you truly believe it's more effective, then far from opposing it, upper management typically assumes that you're going to move in that direction. So when we talk about practices like continuous integration or disciplined refactoring or test-first development, I don't think you need upper management's approval to do those things. In fact, in our experience, typically upper management assumes that you're moving in those directions if those, in fact, are better solutions for your particular context. For those practices that are visible to upper management, so this is part two of my response, there I think upper management has every right to ask probing questions and make sure that the changes you want to make, in fact, are in the best interest of the organization, especially given the problems I've described of some misguided attempts to implement the wrong Agile practices that actually undermine achievement of business objectives. So there, I think the practices I suggest are, talk to the upper management, make sure you're clear about what the business priorities are, make sure that the Agile practices you select are responsive to those business priorities, and if upper management still needs convincing, then maybe you need to do something as formal as put together a business case and explain what changes are going to come about as a result of the Agile practices, how specifically they're going to benefit the organization, and why that's worth doing.
Well, it looks like we're out of time. That was good. Good, lively Q&A. And thank you very much for everyone that participated in it. And thank you, Steve, for your informative discussion. I'd like to thank everybody for attending today's MSDN Magazine webinar, Right-Sizing Agile Development, brought to you by Construx. This presentation will be available shortly in an on-demand format. As a registered user, you'll receive an email with detailed information on how you can access the webinar on demand as you like. Do you have anything you'd like to add before we lock out completely, Steve? Any closing comments?
I'd just like to thank everyone who has attended today, and please feel free to contact me or Construx Software if we can provide any further guidance on this topic.
Good show. Thank you. This webinar is copyright 2009 by MSDN Magazine and TechWeb, a division of United Business Media. The presentation materials are owned by or copyright by Construx, which is solely responsible for their content. The individual speaker is solely responsible for his content and opinion. We hope you'll join us for future webinars. For more information, please visit us at msdn.microsoft.com. On behalf of our presenter, Steve McConnell of Construx, I'm Gary Cocker. Thank you for joining us, and have a great day.